Many of the questions we have worked through in the examples for the lessons within Unit 4 are similar to or based on past exam questions. However, this lesson walks through an actual question from a past exam paper before providing you with the opportunity to work through further questions from past exam papers on the topic of scatter diagrams and correlation. The question we are going to go through is from June 2022 and was included on paper 2 for both the foundation and higher levels. It's a useful question for us to go through as it covers lots of different elements in relation to scatter diagrams. The first part of the question is actually not on Unit 4, but it's a common part of a question that often comes up, so it makes sense for us to use it as revision. Irina is investigating whether the percentage of the population of a country living in urban areas has an effect on the life expectancy in that country. And part A asks us to suggest a hypothesis Irina could use for her investigation for 1 mark. So I'm going to say countries with a higher percentage of urban population have higher life expectancy. As we know, and I've said before, but it's an important exam tip, that when you write a hypothesis, it must be written as a statement, not as a question. Irina collected the following information about 10 countries. The urban population percentage refers to the percentage of the population of the country who live in urban areas. And we have a table. Irina used statistical software to draw a scatter diagram for the information in the table. Part B asks us to give a reason why a scatter diagram is an appropriate diagram to use for 1 mark. I'm going to say that the data is bivariate. Alternatively, you could say that the data is paired or that the scatter diagram will show any correlation. However, you wouldn't get a mark for saying that the data is continuous. Whilst this might be true, it isn't a sufficient reason for using a scatter diagram. An important exam tip is to use appropriate statistical language where possible. For example, here, bivariate, paired, or correlation. Part C says for this investigation, which variable is the explanatory variable, and to give a reason for your answer for 2 marks. So this part of the question, we need to say which is the explanatory variable for 1 mark and give a reason why for the other 1 mark. Now, if we go back to look at the beginning of the question again, we can see it said that Irina is investigating whether the percentage of the population of a country living in urban areas has an effect on the life expectancy in that country. So Irina is hypothesizing that the urban population has an effect on life expectancy. Urban population is therefore the explanatory or independent variable, and life expectancy is the response or dependent variable. So we could write an answer like urban population percent is the explanatory variable because Irina thinks this affects life expectancy. The scatter diagram from the statistical software is shown below, and then we have a scatter diagram provided. Part D says to explain, giving a statistical reason, whether or not this scatter diagram supports your hypothesis in Part A. Now, a question that asks you to explain something basically requires you to look at the data you've been given and write about what it is telling you. So for this question, we need to look back at the hypothesis we wrote earlier of countries with higher percentage of urban population have higher life expectancy. And we also need to look at the scatter diagram. From the scatter diagram, we can see that as urban population increases, the life expectancy also increases. So yes, the scatter diagram does support our hypothesis. So we can answer that the scatter diagram shows a positive correlation, so supports the hypothesis. Note here that the question specifically says to give a statistical reason. So here we need to use the term positive correlation, not just to explain what was happening, but actually use this statistical language. For these 10 countries, the double mean point of the data is 63.9 by 77.8. And part E says, using this information, draw a line of best fit on the scatter diagram. So the first thing to do is to plot the double mean. So we plot it at 63.9 along the horizontal x-axis and 77.8 on the vertical y-axis. And then draw a straight line of best fit through this mean point. It is essential to use a ruler to draw a line of best fit and be as accurate as possible. Using statistical software, Irina finds the gradient of the line of best fit should be 0.19. Part F asks us to interpret the gradient of the line of best fit. Just to remind ourselves of the equation of the line of best fit is y equals ax plus b, where a is the gradient and b is the y-intercept. We don't need to calculate any figures to answer part F, as we are given the gradient of 0.19 in the question. And we don't need to calculate the gradient of line of best fit that we drew, for example. This highlights another important exam tip: to read the question carefully before you start to answer it. So this question is basically asking us to say what the 0.19 gradient means in the context of the question scenario. I'm going to say that for every 1% extra in urban population, life expectancy increases by 0.19 years. Make sure you use the correct units for the scenario. So in this question, percentage urban population and years for life expectancy. Irina now finds that South Africa has urban population 65% and life expectancy 63 years. Part G says determine how this information for South Africa fits with the relationship shown in the scatter diagram for the other countries, and that's for 2 marks. Okay, so we need to look again at the scatter diagram. Although we don't have to plot South Africa on the scatter diagram, it can be useful to see how it fits, and it also shows the examiner that we've thought it through. So 65% on the horizontal urban population axis and 63 years on the vertical life expectancy axis would be plotted here. We can now clearly see that this doesn't fit with the other data points and would be classed as an outlier or anomaly. So I'm going to answer the 63 years is a lower life expectancy than would be expected for an urban population of 65%. It does not fit with the other data. And that's the end of the question for a total of 11 marks. So now it's your turn to have a go at some more questions from past exam papers in the pack that follows this lesson. In it, you will find past exam questions for both foundation and higher levels, along with tips, suggested answers, and marking guidelines. So that's it for this video. Now it's your turn to have a go at some questions yourself.